Today we're going to move on and build up a model of supply and demand based on Unit 8 in our. So prices you can think of as information. During the Civil War, the U.S. Navy's blockade of Confederate states led to a 75% reduction in the supply of American cotton to Britain's textile mills. It also led to a six-fold increase in cotton prices. That led to a shift towards producing cotton in India and away from other crops. It led to the development of technologies to process Indian cotton, and it led to massive investment in these new technologies. So the blockade, through the price mechanism, ultimately led thousands of independent actors to change their actions in response. You can think of market prices like messages. In some conditions, prices provide an accurate measure of the scarcity of a good, and higher prices provide individuals and firms with an incentive to conserve in society's scarce resources. In Unit 7, we were considering monopolistic markets for differentiated goods. In that model, there were many price-taking buyers, but one price-setting seller with the power to choose any feasible price and quantity combination, right, constrained by consumers' demand for the product. In Unit 8, we're going to consider competitive markets for homogeneous goods. Here, there are many price-taking buyers, but there are also many price-taking sellers with no power to choose a price above the market equilibrium price. Price-setting firms then choose the price-quantity combination that maximizes profits. That's what we saw in Unit 7. We'll see that price-taking firms take the prices given and choose only the quantity that maximizes their profit. You can think of the market for used textbooks as a fairly competitive market, right? The market for new textbooks is not similarly competitive, right? Because any given book company, McGraw-Hill or whatever, is always thinking about the downward sloping demand for the book and thinking about whether or not to raise the price and sell it to fewer people or lower the price and sell it to more. Let's think about the demand for used textbooks. We're going to start out with this demand curve showing how much up to 40 different potential customers are willing to pay for the book. Right? Buyers' demand for used textbook is similar to demand for cereal or beautiful cars. Students' willingness to pay will depend on a bunch of things: how interested they are in the subject, how useful they think the textbook will be for the class, right? How much money they or their parents have. You can also represent demand not simply as a curve, right, but as an equation. In this case, the willingness to pay is equal to 20 minus 1/2 Q, where we see when Q equals 0, for example, the willingness to pay of the 0th consumer, which is a somewhat confusing concept, is 20. Right? The first consumer, when Q equals 1, is willing to pay $19.50. And the 40th consumer is willing to pay, right, 20 minus 1/2 of 40. They're willing to pay 0 for a book. There's someone, the 40th person is willing to take the book off your hands, but not pay any money for it. You can also represent the demand as a table, where of course you'd simply put in different values of Q and match that with a corresponding willingness to pay or price in a table like this. Right, where you see the 0th consumer be willing to pay 20, the first $19.50, all the way down to the 40th who's willing to pay nothing. We can use the same method to think about the supply of used textbooks. The supply of used textbooks depends on sellers' willingness to accept. Sellers are lined up from those with the lowest reservation price to those with the highest. In the same way that demand curves line them up from those who are willing to pay the most to those who are willing to pay the least. Right. The 20th seller, for example, in this demand curve, is willing to accept $7 for their textbook. The 40th seller, meanwhile, would need a full $12 to sell their textbook. At a price of $10, right, we could also say 32 books would be supplied. It's because the 32nd person is willing to accept $10, and the 31st, 30th, 29th, and so on, they're also all willing to accept $10 or less, right? So the price of $10, we would get 32 textbooks supplied. Supply can also be represented as an equation, right? In this case, the willing to accept, we see when Q equals 0, right, the willingness to accept is 2, right? And when Q equals 20, for example, the willingness to accept would be 7, right, which is 2 plus 1/4 of 20, 2 plus 5, that equals 7. You could also represent this as a table, although I don't have space to show you that in this particular slide. So what will the market equilibrium price be? Well, markets bring together buyers and sellers. You can think of something like the Grand Bazaar in Istanbul, a famous market, or the Chicago Mercantile Exchange, where futures of corn and soybeans and so on are sold in the United States. And you can think of something like Amazon.com, where there are many people selling a used copy of Greg Mankiw's 7th edition Principles of Economics, and you can buy it for roughly between $55 and $62, it looks like.
So let's move now to an example of a competitive equilibrium with the supply and demand curve. The price of the equate supply and demand, we're going to call the equilibrium price. If the price is too high, there's going to be excess supply. We see that here with the price of $11. For a textbook, we see there are a lot of textbooks supplied. A lot of people want to sell a textbook, but not very many demanded. Not too many people who want to buy a textbook. If the price is too low, on the other hand, there's going to be excess demand. Right? At a price of $5 a textbook, there would be 29 textbooks demanded by people, but there'd only be 12 or so textbooks actually supplied. Competition then is going to drive the price towards the competitive equilibrium, which in this example is where supply equals demand, right, at point A, where textbooks are selling at price P star and there are Q star textbooks selling in every period. All buyers and sellers are price takers, and no one has an incentive to change behavior. So at A, we're at a Nash equilibrium where no one has an incentive to change what they're doing. Now, how do we find A? Well, to find A, you want to set the willingness to pay on the demand curve equal to the willingness to accept on a supply curve. If our demand curve is given by the function 20 minus 1/2 Q, and if the supply curve is given by the function 2 plus 1/4 Q, when we set these two equal to one another, we can solve for Q to find the equilibrium quantity. Right, subtract out the 2, add the 1/2 Q, we get 18 is 3/4 Q, and that Q is 24, which in our figure we see Q does look like it's about 24. Now that we know that Q is 24, we can take 24 and throw it into either the willingness to pay or the willingness to accept equation, and we should get the same price either way. Right? In this case, if we throw 24 in, we're going to get $8. We're going to see that at a quantity of 24 textbooks, the marginal person is willing to pay $8, and a marginal person is willing to accept $8 for that textbook, and so that is the price that we'll see. Alfred Marshall gets some credit for helping develop this model. Marshall and Leon Walras are credited with the development of what we call neoclassical economics. And Marshall's textbook, Principles of Economics, was the standard introduction to the subject for 50 years. Marshall developed concepts of marginal cost, marginal utility, consumer surplus, producer surplus. He also helped mathematize economics, but he cautioned colleagues to use math carefully. He wrote that we should use mathematics as a shorthand language rather than as an engine of inquiry. Keep to them till you have done, translate into English, and then illustrate by examples that are important in real life. Then he said, burn the mathematics. And if you can't succeed in 4, if you can't find useful examples, important examples for what your mathematics is trying to describe, then you can also burn the math. He said, I do this often. Let's consider another example. The demand for bread loaves in a city. Right, so here we see that no one's willing to pay more than €4.25 for a loaf of bread, and a price of, say, 50 cents per loaf of bread, right? People would demand 10,000 loaves. The lower the price, the greater the demand. Right? And that fits the law of demand like we've seen in all the other examples of the book. Now, if we want to go to the supply side, right? Let's suppose that you're the owner of a small bakery. So this isn't a large bakery making bread for everyone. This is many small bakeries feeding a city. Maybe this is a European city. That's why we're in euros and there are a bunch of bakeries because it's Europe. Suppose you're the owner of a small bakery with a fixed cost and a rising marginal cost. Well, then your cost curves are going to look like this. Right? They look just like the ones that we saw or the Beautiful Cars Company, we have a rising marginal cost. That marginal cost comes through the minimum of the average cost, which is the same as the zero economic profit curve, right? And it goes through all the other isoprofit curves at the minimum of those curves as well. So because you have a fixed cost and a rising marginal cost, my average cost falls for a while as you spread out the fixed cost over more loaves of bread. But eventually, once the marginal cost gets above average cost, it starts dragging the average cost back up. Neighboring bakeries are selling identical loaves for €2.35. So what that means for you is that you cannot sell loaves for more than €2.35. You will then decide to sell 120 loaves. And the way you can see that is that's the highest isoprofit curve you can get on. There's a tangent C right here between this isoprofit curve making $80 in profit and the demand curve that you face. Right? That's also the last loaf. The 120 loaf is the last loaf where what someone's going to pay you for it, $2.35, right, is still greater than what it costs you to produce the marginal loaf. Right? So at A, the price that you can't control as a price taker is equal to your marginal cost. So price taking firms are choosing a quantity where the price equals the marginal cost. If you're a price taking firm, you don't have any power to set the price. You simply choose how much you want to sell into a market at a given price. And you want to sell, of course, all the loaves that cost you less to produce than you can sell them for, but you don't want to sell any of the remaining loaves that would get more expensive for you to produce than you could sell them for. Your supply depends on the market price, right? So at a price of $2.35, you're going to sell 120 loaves. But if you raise the price to say $3.20, well, then you can go further up. You're going to sell some more loaves that cost you a little bit more on the margin to produce every one of them. You'll produce all of those that still cost you less than €3.20, right? It'd be 163 loaves. If the price fell all the way to €1.52, all the way down here, right? Well, then you actually can reduce how much you sell. You're going to sell just 66 loaves. If the price falls below 152, right, then you're going to be selling loaves below at less than what your average cost is. That means you're going to be losing money. You can be making a loss in the short run, and your decision about whether or not to stay in business in the long run is going to depend on your expectation about what's going to happen to prices in the future. If you think bread prices are going to come back up, you might stay in the market for a while, keep paying your fixed cost, your rent, and so on. But if you don't think bread prices are going to come back up, that's when you would just leave the market. The marginal cost curve is also the supply curve for price-taking firms, right? As we change the price to find out how many loaves this firm is going to produce, we just go over and find out the quantity where their upward sloping marginal cost equals that price. So we can take this marginal cost curve and we can turn it into a firm's supply curve, where at any given price, the supply curve tells you how many loaves this firm will sell. Now, suppose that the city has 49 other bakeries with exactly the same costs as you. Well, if your firm's supply curve, or your marginal cost curve, looks like this, then the market marginal cost curve, or supply curve, is going to look very similar, right? If you, for example, at a price of €2.35, right, want to sell 120 loaves, well, then if there are a bunch of other firms, 49 other firms exactly like you, the market is going to supply 50 times the amount of loaves that you would supply, because all the other firms have exactly the same cost. The market would supply then 6,000 loaves at a price of $2.35. If the price fell to 152, right, the firm is going to supply, you would supply to 66 loaves. The market would supply 50 times 66 loaves, because there are 50 firms, 3,300 loaves, and so on. And so the supply curve for the market would actually have exactly the same shape as the supply curve for the firm. Just notice the axis here is condensed in so that as you increase the price, right, you don't get just a loaf from one firm, you get the extra loaves of 50 firms. The market supply is the horizontal summation of the firm's supply curve. So the way you get from the firm supply curve to the market supply curve is you say, okay, at a price of $2.35, how much will one firm supply? 120, but then add on 120 for the other 49 firms. That's what gets you to 6,000 loaves. The marginal cost of the 6,000 first loaf is then very close to €2.35, right? You're barely moving up at all to get one more loaf at that point. So the competitive equilibrium price for bread in this example would be €2. If we put together the demand curve we looked at before and this market supply curve. The market then is going to supply 5,000 loaves of bread, and each firm, since there are 50 firms, is going to be supplying exactly 100 loaves of bread. Does any individual or firm have an incentive to change behavior when we're at equilibrium A? Well, they don't. That's exactly what makes it an equilibrium. Consumers are only purchasing the bread if their willingness to pay, right, for a loaf of bread is greater than €2. And firms are only producing the loaves, right? These are all the loaves that are being produced. They're only producing the loaves if their marginal cost, this line here, was less than the $2 they could sell it for. They're not producing any loaves where the marginal cost is greater than €2. What would happen to the price if your firm cut its supply by half? Right? Imagine that you tried to think about this problem the way we're thinking about the problem for price setting firms. Right? With price setting firms, they think about how if they constrain production, maybe they could raise the price enough to make it worth it for them. But here, if you decided to reduce your supply by half, that would have essentially no impact on the price. Right? Remember, you're selling 100 loaves. If you reduce your supply by half, then loaves might sell not for €2, but €2.01 or something like that. We'd be at 4,950 loaves instead. But that very small increase in price would not be enough to justify it from a profit maximizing standpoint for your firm. Your firm is going to lose a lot of money if they reduce their production by half. Now let's think about the gains from trade. The reason economists like competitive markets is the gains from trade are maximized. Remember again that gains from trade is we add together the consumer surplus and the producer surplus. The consumer surplus, for example, for the 1,301st loaf is going to be the difference between what that consumer is willing to pay, €3.50, right, and what they actually have to pay, €2. So you can think about it as this line right here. You can also think about is this triangle here. This is not a perfect triangle because these supply and demand curves are not exactly linear, unlike the example that you'll see in the homework, right? But you could approximate this area with a triangle that goes from €425, subtract out €2, multiply by 5,000, divide that by 2, right? That's going to be a total consumer surplus of about €5,625. That's the difference between what people will be willing to pay for all the loaves they buy and what they actually have to pay. On the other side, we can think about the producer surplus. Right? There's some firm that's willing to accept €1.20 for the 2,001st loaf. Right? And of course, we could add that up for all the loaves that the firms produce. The producer surplus then, right, would be €2 minus €1 if we approximate the shape as a triangle, right? Multiply by the 5,000 loaves, divide by 2, and we get a producer surplus of roughly €2,000 here in purple. When firms are price takers, all the gains from trade are exhausted. When firms are price setters, not all gains from trade are exhausted because there's some deadweight loss. Right? In perfect competition, there's no deadweight loss. Whenever firms can set prices, there's going to be some deadweight loss. Suppose, for example, that only 4,000 loaves were exchanged rather than 5,000. Well, then the total surplus would be just this blue area rather than the entire area to A. There would be 1,000 loaves here where people would be willing to pay more than what some bakery would be willing to accept to produce that loaf. And that's exactly why there would be deadweight loss. You could estimate the size of this deadweight loss by looking at the difference here in price. Here, this is exactly €2.40 minus this is exactly €1.60. Right, so that's the height of the triangle multiplied by the 1,000 loaves divided by 2. The deadweight loss here is €400. If 6,000 loaves were exchanged, there would also be deadweight loss. Right? Imagine that we sold too many loaves, that you kept on selling loaves until there were 6,000 sold rather than 5,000. Then there'd be some loaves that cost firms more to produce than what someone would be willing to pay for them. Competitive markets maximize the total surplus. Price-setting firms set the price above marginal cost, right? So that causes a problem when you have price setting firms, but price taking firms and competitive markets sell at a price equal exactly to the marginal cost. And so there is no deadweight loss in perfect competition. Homework 3.1 is going to give you an opportunity to work through an even simpler example with a linear demand curve and a linear marginal cost or supply curve. And I want you to think a little bit about whether competitive markets are a good institution. The competitive equilibrium is going to be efficient because the participants are price takers without any market power, so that price equals marginal cost. The exchange of bread is also governed by a complete contract between the buyer and the seller. And there's no effect on others besides the buyers or sellers, so there's no externality, as we'll think about in a couple weeks. So we know the competitive equilibrium is efficient, given all of these things. We can also think about whether or not it's fair. And thinking about whether or not the price from bread is fair may strike you as weird, right? It might seem to you like the price of bread doesn't have very much to do with fairness. And maybe it doesn't in 2021, when most of us are well enough off to not have to worry about the price of bread. But historically, of course, the price of bread has mattered enormously. Right? Jean Valjean and Aladdin, they both steal bread to survive. Right? For them, you could say that maybe they were justified in stealing bread given that they couldn't afford the price, that they were put in this unfair situation where they would have starved without stealing it. Today you might not relate to the price of bread, but you might very much relate to the price of renting a home. Right? Here are the rental rates for people living in the Denver area, and they've gone up enormously over the last few years. These are competitive markets though, right? There are a lot of landlords and there are a lot of renters. Nevertheless, rental rates have increased in Denver since 2008 by about 60%. So rental rates are way up. Is this increase in rent efficient? Well, according to the supply and demand model, yeah, it is efficient, right? Supply equals demand, and for the marginal apartment, people are willing to pay exactly what some landlord is willing to accept. Whether or not the increase in rent is fair is less clear. Right? You might think it's fair, but if you're a renter, you might think it's very unfair that your rent's gone up 60% since 2008, but your wage maybe has gone up by much less than that. So there's nothing about perfect competition that ensures us we're going to get to a fair equilibrium. Of course, when rental rates go up, whenever prices change in perfectly competitive markets, one side's winning and the other one's losing. So when there's an increase in rent rate, of course, landlords gain, and of course, renters lose. And of course, with a decrease in rent, it'd be the other way around, right? But you can't make them both better off. There's only so much surplus to be shared there.